So this is a 2's complement normalization. So this is the sort of thing that might come from a paper 2. So in this case, we've got a decimal value of 1632, which is a fairly big number for these, I suppose. First step is to work out what 1632 is as a standard binary number. And so we just apply our usual process. So we look at the first one. Does 2048 go into it? No, it doesn't. But 1024 does. So we can do our calculation with that if we want to. You can use a calculator in paper 2, so it's not the end of the world. But we can always do it kind of longhand if we want to. So we're left with 608. So we need 1 in 512. And again, we can do our longhand. We've got 96 left. So 2 zeros and 64. And 32, and then we've come to the end. So we've decided now that our number for 1632 is 011 0011 0000. All very well. We would have a decimal or a binary point just there because this is our units column. So in order to normalize this number, we need it to be a positive number, and we need the decimal or the binary point to be after the first 0 and before the first 1 here. So we can count them along, and you usually get a mark for this in the exam, even if you don't get it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And this position here is normalized because we've got a 0, 1 just there, and it's a positive number, and it was a positive number when we started. So that means we need to apply an exponent. So we've moved the point 11 places, so our exponent will be 11. And in binary, you've got 8, 4, 2, 1 again, minus 16 here. So that's what the exponent is. So now we've got the answer. The answer is 0, 1, 1, 0, 0, 1, 1. And our exponent is 0, 1, 0, 1, 1. And so that's our points for this one all sorted. So don't be frightened about the bigger numbers. It's very straightforward. All we're doing is doubling every time. And the easiest way to count how many places we're moving is to do this looping thing. In fact, if you do this, and even if you got it wrong, if you do this and show 11 place move like this, even if you didn't write down exponent 11 or this correctly, you would still get a point. So it's well worth doing that in the exam because you get a mark for it. So that's normalizing floating point with a 7-bit mantissa and a 5-bit exponent.